Let's go over sketching of exponential functions. I'll start with something simple. Let's say you have got f of x, which is 2 to the power x. When the power is positive, how do you get to sketch that? You can use a table of values if you want, just to see how it's going to be going, but to realize when we are sketching, you don't need a table of values. I can make a simple one. We've got x values and y values. I'll just use 3. I can start with a negative 1. If I put negative 1, so it will be 2 to the power negative 1, that is the same as 1 over 2, which is 0.5, will be the value for y. And then let me put 0. We know in numbers to the power 0, the answer is 1, so that will be 1. Let me also put a 1. 2 to the power 1, the answer is 2. So we are saying if x is negative 1, 0, and positive 1, and then let's say this is a 2, this is a 1. So negative 1 comma 0 0.5, 0 0.5 will be somewhere here, and then 0 comma 1 there, and then 1 comma 2 here. So this function goes like this to continue going up, continues to go up like that. Now, one thing that you can, it's not showing now, just give it a moment, it's going to show. One thing that we are able to tell from here is that for an exponential function, whatsoever the base, as long as the base is positive and then the power is x, we don't care what the base is. It will always cut through the point 0, 1. Like that would be the y-intercept 0, 1. Okay, so the y-intercept is going to be 0, 1. Doesn't matter the base. Maybe something that would have just changed is if the base increases, then this thing is going to turn all the more like that. Something like. Now, let's say what happens if we make the power negative. So let's say we have got 2 to the power negative x. Now for such a function, what will just change is the direction. X will be going towards the negative values. That's the meaning. Okay, so now the function will go like that. It will still cut at 1. The x-axis is an asymptote. You don't touch that. So here to continue going down like that, it will not touch. So what is going to happen if you make the base negative? If you make the base negative but x is positive, you are going to be going towards positive x values but towards negative y values. So meaning that this is going to be increasing like this. Negative y values but towards positive x values, it will now cut at negative 1. And that will happen when x is 0. What happens when both x and y are negative? To be going towards negative values of x and also towards negative values of y, meaning that a function be going like that. So basically this is how you get to sketch an exponential function. So constants which are going to be adding or removing from this function will just be shifting the graph in the y or in the x. Let's say we have got f of x which is equal to 3 to the power x. Now you say plus 4. You're adding a constant 4. The question is, what does that 4 change? So this will change the y value. It is now at 4. This is like the reference point of the graph. This is where you will not touch. That's what you can consider it like that. Okay. So because x is positive, and then you have got also the function here being positive, meaning that the function is going to, you expect to be going up like this. You can try to think of it. If x is 0, put 0 here, y is going to be 4. Okay, what of if x is equal to, let's say, 2 or 1, put 1 here, y is going to be 7. What of if x is, let's say, negative 5? This will be, or let me say negative 1, this will be 3 to the power negative 1, which is 1 over 3. 1 over 3 plus 4 is still a number which is above 4, meaning the function can't go below 4. Are we together? Okay. So basically that is what constants added are going to be able to do to the function. Let me change just this. Let's say we're talking about, let's say, negative 3 minus 2 to the power negative x. Now, the base can't be a 1 when you're talking about exponential functions. So already you can see we have moved this to negative 3. So we will not be able to cross this line. And then we can see the base is negative, meaning we're going to be going towards negative values of y. X is also negative, we'll be going towards negative values of x also. So this function is going to be moving like that. So this is always supposed to cut like 1 unit from where you can't touch. So meaning that it's going to cut at negative 4. When x is 0, put 0 here. Any number is to the power 0, the answer is 1. So it will be negative 3 minus 1, which is a negative 4. So that's how you determine that value. Now let's say y was positive like that, meaning that the function will still be going towards negative values of x but towards positive values of y, meaning that the function could have gone like this, or it can pass through the center, or it can cut here. So to determine where it's going to cut, make x 0. So this will be negative 3 plus n numbers to the power 0, and answer is 1. So it will give us a negative 2. So it will come and cut at negative 2. Let's say negative 2 is here. So the function will be going like this, and then it cuts like that. So we also need to find this point where it cuts the y-axis, the x-axis, and that we know that y is 0. So we're going to say 0 is equal to negative 3 plus 2 to the power negative x. So this will give us 2 to the power negative x being equal to positive 3 if we take 3 the other side. And then from here, we of course can introduce a logarithm at this point, where I can say this is 1 over 2 to the power x being equal to 3. I'll cross multiply. This will be 2 to the power x, that will be equal to 1 over 3. To do away with to make x up the formula, I'll introduce natural log or just a log. So natural log of 2 to the power x is equal to natural log of 1 over 3. So this will give me x natural log of 2 being equal to natural log of 1 over 3, meaning that x is going to be natural log of 1 over 3 divided by natural log of 2. This is where it is going to cut at this position. So that's the x value, but y value is 0. So if you want to write it as a coordinate, you write natural log 1 over 3 divided by natural log of 2 comma 0. So that's the coordinate of that position. What happens when you get to add or subtract something from the x, which is the power? So I've got f of x is equal to 2. Now you have got x plus 1. So this one, the shift that you are going to see is where it gets to cut. You will not necessarily get to feel that much impact on the shift. You can see x is positive, the base is positive, so expect the function to go like this. But it will be different where it gets to cut. It will not cut at 1. Okay, you want equate the power to 0. X plus 1 is equal to 0, meaning that x is going to be equal to negative 1. So when x is equal to negative 1, that has made the power to be equal to what? 0, meaning that 2 to the power 0, the answer is going to be what? A 1. Okay, so for us to have a 1, it will not be at 0, meaning that for us to have a 1, it will be negative 1, negative 1, comma 1. So it will be somewhere here. So since this is a shift that has happened, so if you want to find this position, you know that the value of x at that point is 0. Okay, so we'll put a 0 here. 2 to the power 1, this will be a 2. So this is a shift that has happened. This is what happened. So we have shifted. When you add a positive number here, you are going to shift the function in this direction to the left because you equate it to 0, meaning that for you to find a 1, you are going to not find it when x is 0, but when x is equal to negative 1. That is the shift that gets to happen. Let's say I want to sketch f of x, which is equal to 1 minus 3 to the power 2x plus 4. Let me say minus 4. So already for this function, we have got a 1 that is going to shift in the y direction there. So we'll not touch this line. And then let's equate the power to 0. So 2 to the power x minus 2x minus 4 is equal to 0. We're going to find that x is equal to 2. So when x is equal to 2, which is somewhere here, this is where we're supposed to have 1 unit. So 1 unit from the point where we're not touching. So that is at 2, right? 1 unit up. So this is where we'll not touch. Like this is where the function is going to get to cut like that. I don't know if it's getting to make sense. But now because this thing is negative, means that the function is going to be going down. So it will be 1 unit below. From 1 unit below is at 0. So it will be here. That should be the one. Okay. When we put a 2 here, 2 times 2, that is a 4. 4 minus 4 is a 0. 3 to the power 0, the answer is 1. 1 minus 1 is 0. We can confirm, right? So it will be here. So meaning that the function is going to be going towards negative values of y, but positive values of x. Okay? So positive values of x, but negative values of y. This is how the function is going to be going. So our aim is also to find this point here, and that of course is when y is 0. Sorry, this one is when x is 0, not y being equal to 0. When x is 0. So when x is 0, we put here 2 times 0 is 0. 3 to the power negative 4, so that will be 1 minus 3 to the power negative 4, which is 1 minus 1 over 3 to the power 4. So whatever the answer that we get here, that is going to be the y value which we are going to have at this position.